to the top, and you can go to design and quick layout. And that's my quick layout right there. It's my favorite one. You can also get to the chart title, click on all this stuff. Yeah, also, I'll show this again real quick. Got all these options, got so many cool things, it's so nice.
Gary! I was just looking for the sports channel, Gary.
Hey everybody, how are we doing? Muhammad is here, Claire is here, Hannah's here. Let's see if we can fix that issue, Claire. Sorry, Muhammad, I reset the points so that way there's 0 points for everybody, because sometimes you'll go from like 201 to 320 to 474, and I was like, oh no, I gotta reset the points between semesters. So at the start of every semester, I'll reset the points. But Muhammad, with 41 hours, you know what? Muhammad, I might just make you, no, because let's give Muhammad a free 1,000 points. I'm not gonna break the point economy this semester, Muhammad. So since I know you're a former student, so let me go to users. If you have questions, let me know. We're just getting started right here. Currency, but let me go here. Muhammad, edit, because I can edit points. There, Muhammad, gave you some points. Because I'm like, no, I feel so bad. Because Muhammad took, I think, you took 201 and 320. I don't think you've had 474 with me yet. Have you, Muhammad? And Claire, feel free to say, I'm struggling on getting AMP to work. Oh, JMP. I thought AMP. I was like, AMP? Well, let me open the files we need for the visualization. Are you on a Mac or a PC, Claire? Are you on a Mac or a PC? Are you on a Mac or a PC? Mac. So here's what I want you to do. I want you to hit, I'm going to go to the main screen here. Main screen. I want you to hit Command and then Spacebar. Spacebar. So first thing to do is hit Command Spacebar. This should bring up a little window right here, and it's going to bring up a search, a global search on your computer. And when the global search shows up, I want you to type JMP. And what you'll hopefully see is a little like greenish icon or so. I can't remember what the jump icon looks like, but it'll be like a green icon, not red, not Christmas. And you'll see like the jump icon, you'll click it. So tell me if that shows up. Because if that doesn't show up, then jump is not installed. So when you hit Command Spacebar, you should see it should pop up a global search, and then you'll type JMP. And does that show up, yes or no? And then does it have a green icon next to it, or does it look different? You might have to send me a screenshot. Yeah, I think you can screenshot that using Command Shift 4. I might have to hop on like Zoom with you and look at this. Like we might have to like, or Discord, either one. But either one of those, we might do that. So is it green, or does it have like DMG next to it? Because then it's like the download file or something. I'm drinking coffee again, Muhammad. I ran out of creamer, but milk and coffee, not so bad. I've been drinking coffee for like 5 months. It about drove me to the brink of madness. No coffee. I've got my coffee back. So is it a green icon, or is it a gray? It's weird that you won't let you click it. This is where like being able to see things is so much easier. Because right now it sounds like it's not installed properly. And if anyone has questions, let me know. If you have questions, feel free to ask. We did visualization 1 already. We did visualization 2. We did visualization 3. We can talk over anything people are stuck on or have questions on. So let me know your questions. Your comments, your questions. Adjusting my screen sizes. How's it looking, Claire? Let me see here. I'm going to hop back to space really quick. Oh, so awesome, Adam. Glad you're stopping by to just hang out. That's awesome, Adam. Appreciate you having you here. I'm going to see. I don't see Claire's thing. I'm looking Discord. A lot of people want the Discord link. I'll send that out later. Pokemon Go. There we go. Cool. Got a lot of emails. Respond to them later. So awesome to have you here, Hannah. We could talk over. Adam, you're in 320 right now, right? Adam's in 320. I think Hannah's in 201. Oh, Evelyn, so good to have you here too. I'm in Texas. I am a Texan right now, all the way down in Texas. I still like Knoxville the best. Sorry, Texas. I mean, one of these days we're gonna get like Torchy's tacos and stuff. Oh, 65. That's like the best. Good Pokemon Go weather. Love some Pokemon Go. All that good stuff. You know what? I'm gonna show. Let's show a little bit of coding right here because one thing that's really awesome is people are so afraid of coding. Like people are like, coding, I can't code. Also, a bunch of kids, a bunch of like little kids or something. Oh no, I'm getting crow's feet. Oh. Let's talk about some data right here. Okay, so we talked about data in 201. So we've done a lot of 201. You can ask any question you have. So if you're listening and if you're hanging out, just chilling out, so good to have Evelyn here and Hannah here, Evelyn Claire. Please tell me if you just want to be called Evelyn. I'll say Evelyn Claire since it's your first name right there. Check this out. So what I want Adam, can you tell me what I am doing right here, Adam? Let's go right here and do the following. Or let's do this. Sure. Let's go here, ages. Okay. These are guesses. I don't know how old everyone is. What is this going to do right here, Adam? Can Adam explain to people what this will do? This is good practice for 474. So I'm going to label this part of the stream 474 practice. You should be able to read this code, and we're going to walk through it step by step and be like, what does this code do? Like, let's think about what this does. I feel like it's too big. Yeah, better. What does returns a list or vector of those numbers? Pretty much. So we could just do this, and this will just return a vector of these amounts. So the C stands for concatenate, which is basically like gluing things together. Like try to put this in context of something you know. Like I'm just going to glue these things together. So this is the first thing I'm gluing, the second thing I'm gluing, everything is glue. Good song like Jenna Marbles. So everything right there is glued together. Heck yeah, we play Smash. Smash is awesome. Thank you, Scott right there. Smash is great. What's your main, Scott? Gotta go Sam. Oh yeah, Scott's asking me my main right here. Samus. Samus is my main. I'm so bad at the new Smash. Like I'm embarrassingly bad. I'll just put that out there. Claire, I will call you Claire. Smash is awesome. Are you like Link or Roy or Marth? See, I'm old school math. Game & Watch, some Game & Watch right there. That's classic. I've got a Game & Watch. I've got the Bomber Game & Watch. Or it's like Bomb. It's not Bomb Sweeper, but yeah, I play Melee. Melee is GameCube, right? Because there's Smash, there's Melee. Why can't I think of? Is it Ultimate's the newest one? Smash Ultimate's the newest one, I think. It's Melee, and then Brawl. Brawl's the one between that. Melee, Brawl, Smash, Melee, Brawl, and Ultimate. I play more Melee, GameCube. That's all we played in college. Dude, I was in college 2001 to 2000, 2005. So which I think would be helpful this for. So the good thing here, we'll hop back to coding. Now that I got to talk about Smash. You know, we can make this, let's just ask this. Main in Smash. Let's say main in Smash. Okay, so tell me your main in Smash. Mine is Samus. Samus. Someone else tell me their main in Smash. We got Game & Watch. Anyone else have a main in Smash? I'm back. But it won't let me click it on it, and it opens and tells me the license is expired. Let me drop that in the chat for you, Claire, while other people mention their mains. And we'll see what this code is doing. I'm going to drop this in the chat for you, Claire. This should help solve the problem. Tell me if it doesn't, but this video shows how to get the license going. Does anyone else have a main in Smash Bros? And let's explain what this is doing. So that should help with that issue, Claire, right there. What else? We have this right here, and let's look at the differences in this code. So does anyone else? Adam, do you have a main in Smash? I know a lot of people like Link. You're welcome, Claire, of course. And this is just going to the next line on the code. So we're going to the next line right here. What else do you feel like? So many people use Kirby. Kirby's a good starter character. I mean, you know, it's easy to do the up move to stay on. Play Kirby too. Like, I mean, Kirby's not bad, but it's like there's complex characters. Like, you know, some of them have a lot more different move sets. Like maybe Wii Fitness character. I've never played Smash on Brawl other than the Wii. So yeah, who do you like? Who do you play? Let's go right here. We'll add in one more. Let's go here with Kirby's bad in Melee. Yeah, Kirby is bad in Melee, right? Platoon. Oh yeah, that's a good one right there. Let's grab it. She's like the goddess lady or something. Thank you right there, Hannah. So we're dropping that right in. So what we have right here, who notices the difference between the colors in these vectors? Both of these are vectors. I could have very easily done this. So this just creates more space. Falco, we got Captain Falco. He's Captain Falco, right? He's Star Fox, Falco. I'm just gonna go to a new line. It reads through the commas right here. No, you're chilling. This is office hours. No, this is we're talking Smash right now. We're bringing it on topic right here. So you're fine. we're learning like what's going on with this via talking about Smash Bros. I mean, that's the best way to learn stuff, right? So notice what I've done here is I've created a vector of Smash main and Smash. So what happens when I run this code right here? We could talk. If I knew more about Rocket League, we could. Does everyone see that I ran this code now? With this code run, what do you think this 1 through 7 means right here? It says 1:7. What the heck's going on with that? 1, 2, 3, 4, 5. Ah, wait a minute. I think I'm understanding something. There's 7 elements in this vector. So this is the first element, the second, third. The spacing doesn't matter because it's just to make it look nicer, and you can space it out however you want. It just reads through commas and goes to the next line. Just makes it a little more organized sometimes to do spaces. So there's 7 mains in Smash, but there are some repeats. So check this out. We have 3 types of variables. To your Stat 201, you got to show some knowledge here. What are the 3 types of variables that we have? What are the 3 types of variables? And then 320 is going to add a little bit more info to this. I'll try to clarify whenever we're talking like Stat 201 stuff or 320. So what are like, when we talk about 3 types of variables, we're talking about what? What are the 3 types of variables? And Scott, you're always welcome here. We like positivity. You're not bothering at all. Smash is a very positive thing. What are the 3 types of variables? Am I the only one who knows? Yes, thank you, Maddie, right there. Maddie hopping in, helping out. Love it. So we got quantitative categorical identifier. Thank you so much, Maddie. You know what? We haven't given people points today. Let's give some points for jumping into office hours. So if you're here right now, let's do 20 points. I'm going to remember this semester I give out 20 points. You're getting a glass of milk. So we gave out some points right here. Let's do it. Let's go. So we've got the types of variables right here. And with the types of variables, right now we can see how it is. Man, a nice job. Already 1 point on your final grade. The trek up the rest of the mountain's longer, but Hannah, you're leading the way. Nice job. You got it, Scott. W for the win right there. So right here, do you see how this says CHR? That means it's a character vector. So these are words. So the way R sees this, like Jump sees variables with this identifier over here. This is how Jump sees variables. Can you explain how to include variables above the bars in the bar chart for visualization too? Yep, Maddie, you got it. Here, I'll finish this example and then I'll mention that. Great question, Maddie. Hannah just leading the way. I love it. So watch this. I want you to think about, maybe you've never coded. Who can understand what this code's going to do right here? Do you see how when I run these codes, it stores into that? Like I just created this ages thing right here. So ages was created, or ages. Watch this. Remove ages. Hope I'm on the wrong part. Remove ages. Ages is removed. Now it's called age. Better name for it. What will line 6 do on the code? What will line 6 do? It's going to run a function called factor on this. So it's going to take this right here and do what to it? What will it do to it? It's going to take this and do what to it? What will that do to it? It's going to turn it into a what? Well, it's going to do what it says it's going to do. It's going to take the main and Smash, which if we look at what main and Smash is, it's just this thing. We stored into it these names right here. And then it's going to turn it into a factor, and then it's going to overwrite it. So watch where it says CHR for character, and that turns into factor with 6 levels. There's 6 levels because Kirby repeats. And watch this. I think we can do this quickly. When I do plots, I do them a lot nicer than this. Figure too large, of course. It says you made too big of a graphic. There you go. There is a bar chart inside of R. And if we were to change this and make like another Kirby here, we could then replot it. And there you go right there. We can talk more about this here in a moment, but I just kind of wanted to show how you'll notice right here, we have the 2 types of variables. And notice that this is quantitative, that R sees this as numeric, and this is categorical. and R also sees this as a factor. I can make it an ordinal categorical. Maybe we'll go into that in a moment. But Maddie was wondering, can you explain how to include the numbers above? Maddie, are you on a Mac? I'm guessing, Maddie, you are on a Mac. Tell me if that is true, Maddie, that you are on a Mac. Because I need to send out this reminder about this. I'm guessing, I'm pulling up a video here while we talk. My guess is that you're on a Mac. And there's a small issue. Don't worry, it's an easy fix. But let me go grab this. Okay, here we are. And then let's bring this over here. Is Maddie on a Mac? Let's find out the answer to that. The answer is yes, Maddie's on a Mac. Adam, you are 100% right. Adam knows the issue right here. So I'm going to drop this playlist in the link. If you're having an issue, I need to be careful because this playlist has videos from last semester, but apparently this, I don't understand why this happens with Jump, and I had to record this on my Mac and then send it to myself and edit it over here. But
with the numbers appearing above your bars, there's a way to fix this. Let's go ahead and make a graphic here with a bar chart and add in the counts. And
where are the counts? Like Brian, I did what your video said.
Make a graphic here with a bar chart and add in the counts and put the labels on. Now these labels will appear, but let's see what the problem is. We're going to go here to the Apple and go to System Preferences.
I'll rewind it.
Now we're going to go to the upper left button and click on General. Under General, we can change from light to dark mode, and you'll notice when we go to dark mode, the numbers disappear. So going back to light mode will make the numbers appear, and then you can click Done and take your screenshot. Back to dark mode, if you're having
so just so you can see again where to go.
Now these labels and preferences.
Here we go. Let me show it again. You're gonna go to the Apple. So this video is in the chat right now. If you're watching this video is in the chat, and I'll send out reminders on this. Just
here. But let's see what the problem is. We're gonna go here to the Apple and go to System.
So Apple System Preferences.
Now we're going to go to the upper left button and click on General.
So you go to General right there.
Under General, we can change from light to dark mode. And you'll notice when we go to dark mode, the numbers disappear.
There we go. Great question right there. Thank you, Maddie, for asking about that. And that's why I do office hours here. I know a lot of the answers to a lot of the questions. Sometimes, like Adam would know that too. Adam was saying it before. He's like, another night mode issue. I have no idea why this happened in Jump, but for some reason, I don't know. So talking more about coding again, right? And please ask questions if you have it. I'm going to answer every question. I'm just kind of utilizing time right now since we've done visualization 1, we've done visualization 2, and I put timestamps so people who come back to watch these videos can like use them for resources. So, but if you're here, you get to ask the questions. And then I do things like, if you're like, hey, can you explain how this functions works? Or hey, can you explain this? Or hey, this is not working. We work on everything people want in office hours. And then I try to fill the time with extra stuff. So what I want you to think about right here is, what will I get? What do you think will happen if I run plot age right here? It's not going to give me a bar chart. What it'll actually give me is rather interesting. It actually gives me a time series plot of the age by the orders of which they occurred. Now, this is a little bit complex, but I want you to be very careful when saying this. Is this a univariate or a bivariate display of data? So this is 201 relevant right now. Is this a univariate or a bivariate display of data? Now, I know I only put age in there, but take a look down here. So is this like... No! There we go. I'm failing at what I do. Is this univariate or bivariate? Is it univariate or bivariate? And I'll explain all the nuances to this. But when we say it's univariate, that means only one variable is being displayed. When we say it's bivariate, that means 2 variables are being displayed. And although I only put in one variable to be displayed, this display is what? Which that really gives away the answer. Although I only put in one variable to be displayed, this is a what display of data. And let me do this. I'll show you. Yeah, it's bivariate. It is like, and I'll watch this. So what it's actually doing is it's actually, that'd be right. Do you look at this real quick? I'll vanish. So this is the original graphic, and this is the graphic with two variables. Do you see how index is the x variable? This format right here is plot y tilde x. So you put your y variable right here, the one you want on the y scale, and then you put your x variable right here, the one you want on the x scale. So when I do this, age goes on the y scale, and this goes on the x scale right here. But when you put in a quantitative variable by default, it'll do an ordering thing. So there's default data sets inside of here. Like there's the index of these, like it's the order by which it occurred. MTCars is a data set with like a bunch of car data. So if you look at this data set right here, I think we put in the miles per gallon. You see how it's like 21, 21, 22.8, 21.4. Does this make sense right here when you look at these values and go down here by these and you're watching the index of them, which is the order by which they occur? Does that make sense what an index is? Like this is the first occurrence, the second occurrence. Yep. Now, what could we do with this data right here, this data set? And I'll explain what this means in a second. But what could we make? A histogram. How many variables, and Stat1 should know this instantaneously, how many variables does a histogram explain? Or how many variables does a histogram show? I'll vanish on the screen. How many variables does a histogram show? This is not a trick question now. This one's not a trick question. How many variables does a histogram show? And actually, we'll be covering this Wednesday and Thursday for Stat1. One. Don't worry, Adam. It's one variable. I know we were just doing two because plot doesn't index, but right here, the frequency is just the count of how many. But don't worry, Adam. You're doing an amazing job. You know what? I'm dropping another 20 points in the chat. I really appreciate everyone being here. People are afraid to get answers wrong, but the only way to get the right answers is to say the wrong answers. I think oftentimes you remember more what you get wrong in class than what you get right, because if you say something that's correct, you just reinforce knowledge you have. But if you say something that's wrong, your brain reorients. You're like, wait a minute. Histograms are univariate displays of quantitative data. So univariate display of quantitative data. That is something huge that we should know for 201 and 320. So a histogram is a univariate display of quantitative data. You know what we could do really quickly? Watch this. What do you think a box plot is? A box plot is a what? A box plot is a univariate display of quantitative data. So histograms and box plots are both univariate displays of quantitative data, and it's so easy to change that. But let's look at this right here, Adam. What is the deal with this? And maybe it'll help if we kind of take a look at the MTCars data set. So what I'm going to do is I'm going to take MTCars because this is a data set that exists inside of here, but it's like you know how your computer comes with like Minesweeper and video games that are already installed? This is like a pre-installed video game inside of R. So it exists, and you don't have to have it exist right here. It's something that exists without you having to put it in the brain of R. But we put it in the brain so we could view it. And I want you to look at this MPG, and that's just a what inside of the data frame. So this is called a data frame right here, and the MPG is just a what inside of the data frame. So when you see MPG, this $, that's going to take a data frame and connect it to the what? A variable or a column. I was thinking variable also, but I'm just giving another name. The variable inside the data frame. Does that make sense? And what's even better is you get an autocomplete after 3 letters, and look at that. All of these right here are the columns inside of here. Does that make sense how I can select any one of these columns here by just going through? So understanding that the $signs let us reach inside of a data frame. So it's like you're saying, go to this Excel spreadsheet, and once you're inside of it, Mubot's talking away. Mubot. Be good, Mubot. So MTCars is like a database, and you can choose what you want inside the database. Exactly. You can even run commands on the whole database. Let's take a look at that. So if you were to go here and go summary of MTCars, it'll give you a summary of the whole database that quickly. So you can get every single variable summary with the min, the 5-number summary, and the mean. So it's mainly 5-number summary and the median, and the mean, excuse me, which the median is part of the 5-number summary. I wonder if you can run max on it. Probably just gives you the max. Yeah, there's the maximum of the whole data frame. There's the minimum, or you could go to a variable and get the minimum of that. So you can run functions on data frames, or you can run functions on variables inside of data frames. Is this making sense, Adam? Like what's going on right here when here's the data frame, and this says find me the minimum of the data frame. And then this says find me the minimum of horsepower in the data frame. So that's the minimum horsepower of a car in the data frame. So it would only go to that vector. Scott, you're cracking me up. It's I wouldn't call it a filter exactly. I mean, I think you can think of it that way, but it selects a variable. Does that make sense? So, I mean, it was a filter. It was a filter. It kind of is. I mean, yeah. Here, I'll bring up some more data so you can see. Oh, I'm not going to have this. Did I install that recently? I guess I did. If you do not have this, so if you're running these commands with me right here, then you'll need to run this first. Let me explain what this does. This is important stuff right here. So install.packages, do you have Steam, Adam, or do you have Steam, Scott? Do either of you have Steam? Just going to freeze. Because if you have Steam, the analogy will make perfect sense. I actually asked you this other day, but you didn't see it, and yes, I do. Oh, you asked me that and I missed it? Oh, I'm sorry I missed it. So if you have Steam, this is Steam. Does that make sense? Oh, how to install packages. Good. This will sound good right here then. What RStudio is Steam. Does this make sense? Like this is Steam. This is downloading a video game to Steam. Like when you download a video game. As long as you don't delete video games, how many times do you need to download a video game from Steam? How many times do you need to download a video game from Steam? So as long as you're not deleting video games, just once. So I'll put this command in chat right here just so you can get it correct. And let me explain how the command works. The command works the following way. You're asking for it to go and install a package, which is basically just like additional features for R, just additional things you can put in. Always hit enter right here and let autocomplete do its thing. You then have to put the name of the package in quotes because it's going to search for a name. You don't want to put an object like Brian because that's the object Brian. You want to put the name of the package in quotes, and then it's going to search for that name of that package on the CRAN server, which is the R server where our packages are located. Don't switch servers unless you're... I don't even switch servers because even now I'm like, because you don't know what you're downloading if you switch servers. Right. And by default, you're on the CRAN server, just in case anyone's worried. Okay, I'm good now. So what we do here is we first download the video game. And after we download the video game, what does this do? What does this do to the video game? Like you download a video game and you're like, okay, I'm good. I got the video game. What do you do after you download a video game? Run it. So how many times do you need to run a video game? How many times do you need to run a video game? Like when you turn on Steam, do all your video games turn on? Because that'd be weird. You like turn on Steam and like Witcher's running and all these other things and Among Us is running and I don't even know what else is on Steam. King's Quest, Police Quest, Space Quest, Heroes Quest are all running. Gold Sierra games. Every time you want to play it, exactly. So the reason your libraries, and there's default ways to get libraries to load up, but they're sometimes frowned upon because of what if you send someone your code and they don't have the package running. So a lot of times you want to call your packages when you're doing it. And you notice the package is already on, so I don't need to rerun the package. Now that the package is on, I can access things inside of the package. Watch this. Survey, if I knew how to spell. Survey. Oh, I know what I did. Wow. I've drank a bunch of coffee today. So survey 10 is a data frame inside of the reg class package. Do you notice right here, it has reg class next to it? So this is telling me this is inside of the reg class package. Anytime you call functions, you can see where they're inside of, like this is inside of method, this is inside of utilities, and it doesn't have to be functions, it just tells you what anything is inside of, like this is our utilities, this is our methods. Like if I do this, you can see this is base R, this is ggplot, this is R part. It'll tell you what it's inside of. Does that make sense what this is telling me right here? Like if you type this, it won't show up on yours because you're probably not running ggplot2. So ggplot2 is a package that I have, and you can view it over here, like all the packages I have running right now. And that's why you don't have every package running. So what I'm going to do, hopefully is making sense right here, Adam. Really good talk on this. This is going to now load a data set. So watch up here, watch right here, and watch as a data set loads. I just loaded data into R because the package had it, and that's a graphical error. I finally figured out, I think, how to make that not occur. It's just because it saw my window was not right for that. So we've loaded a data set. So check this out. I now have data. I now have the Stat201 survey from 2010. This is the 2010 Stat201 survey. Oh, stop. The 2010 Stat201 survey. If I want to, let's say, talk about heights of people in Stat201, I could look at survey 10, $, and look at this. I just click it, and here's all the heights. Does that make sense that I now can view all the heights of everybody in Stat201? I want you to take this right here and tell me how I could get the mean height of individuals. How could I get the mean height of individuals? What would I do to this to get the mean height of individuals? What would I do to this to get the mean height of individuals? What would I do to get the mean height of individuals? And if you're into a one, I promise this is not too complex. You'll be like, oh, wait, that's... Because you'll see a real cool trick here in a second once we get... Close. Take the vector, though. You could do the mean of... We don't want to do the mean of the whole survey, which we rarely do operations like this on a whole data frame, because that'll get the mean of the whole data frame, and actually it got mad because there's NAs. So we have to do NA.remove equals true. I can mention more on... Oh, it's super mad at me. It really doesn't want to do that. So we don't want to do it of the whole survey. We want to do it on the vector. So we want to go in front of here and go mean of that right there. Does that make sense right there, Adam? That I'm taking the mean of that vector. Like here is a vector of numbers. Like this right here is just a vector. And so we can see it visually. It's just this column of numbers right here. If I go all the way to the bottom, the last number I will see is 71. So you can see right there, 71, 73. It's just returning all these numbers and just winding them around the screen. So I can get the mean of all these numbers right here, which is just a column in the data frame. Yeah, sure. Yeah, definitely. It's just the mean of it. And whenever you're typing a function, here's what I want you to do. Try this right. If you're in R right now, Adam, which I think you are, I only want you to type 3 letters and then pause. As soon as you type 3 letters, I want you to hit enter. And here's the reason. Let's say you have caps lock on. Here's what R will do when you hit autocomplete. Even though that's capitalized, which it shouldn't be, when you hit autocomplete, R will set the capitalization correct. So survey 10 is capitalized, and I just hit autocomplete, and now I can down scroll, and I still have caps lock on. Like I could type it in incorrectly, and if I don't turn off, or if I don't fix that, it'll get mad. But if I use the autocomplete to fix it, autocomplete will fix it. Is that making sense there, Adam? Autocomplete is so huge. Just learn to type 3 letters and hit enter. Makes life so much easier. Like, why type the whole thing out? If you know what you want, you can just type 3 letters and then be like, click, 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 click. It'll speed up your coding so much to autocomplete. And there's a lot of cool features. So I just ran mean and returns one number. Is that right? Yep, that's right. Because the mean is this one number right here. So this is the mean of this vector. So that is the mean of that vector. Is this making sense right here? What else could we turn this to? Let's type median. There's the median. Let's type min. Do you see it just goes to this vector and it finds any of these values? IQR? Why not? Range? The range returns 2 values, which is weird to me. I wish it just returned the range. And you know what's really interesting about this? When you do the... See. So I never liked that it does that. I was trying to think of a quicker way to get it to just return the range of the values, like the numeric value of the range. Because what you can do is you can do this right here. Here's a next step to this, but this should return 26. There we go. What value is this returning right here when I put the square brackets 2 next to it? We'll talk about this next right here. We'll talk about positions as we just kind of talk about coding and learn, because it's a lot of learning by doing. So what is the square bracket doing? It's returning the thing where? What is the square bracket doing? Like if I have an object, we'll make it simpler to see. I have an object X, which has numbers 1 through 10 in it. So if I go, it returns the thing in that position. So what will this return right here? This is a pretty easy example. What will this return? So if I have x is the numbers 1 through 10, you can see it over here above my head, it'll return 4. So you'll have to cheat and look above my head. What will this return? You have to cheat and look above my head to find the answer to it. You have to cheat and look above my head. What will this return? I'm going to even, yeah, I think you're right. Yeah, we can see it right there. Good. You see, actually, and I shouldn't have, be pretty interesting. Let me see what happens if I do this. Okay, so the reason is the way it's reporting this up here is not the same as the way it reports the vector. If we were to look at the main and smash vector, it goes Samus, Game & Watch, Kirby, 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 Platunia, Falco. These are the levels. The levels are not necessarily the values in the order. Yeah, so Java starts at 0, it indexes at 0. I wish it would maybe say something like, we don't index at 0 at R, so it doesn't return anything. It returns, this is a vector of length 0. That's what it's saying when it says factor 0. It's saying nothing to return because there is nothing in that position. So always remember R indexes at 1, and you can see the indexing right there. I'm probably not going to get into, I could get into levels, but I think a good thing for us to talk about here in the moment, I'll label this in the video, is positions and vectors. And R starts off at position 1. So let's talk about this X thing again right here and do the following just so everyone can see. Okay. What will this return? Like putting this on the test right here is a decent test question. Like people should understand this portion of coding pretty quickly. What will this return when I run this code? Like think about reading it like a sentence, like return to me the blank of vector blank. Yep, it'll return 2. Return to me the element in position 1 of vector x. So that's going to go to position 1. Just always read it like a sentence. Go to position 1 in vector x. Return the element in position 1. Does that make sense as we just repeat? Return the element in position 1 of vector x. And this is just making a vector and storing it into like the object x. This is the object, I would call it. Is it object oriented? I don't know. I did a little too much Python. Nick, if you're watching this, man, you know Python way better than me. I got to get my Python skills up. Okay. So, interestingly enough, we talk a little bit about vector mathematics. You can go here, and you can add vectors. Yay! So much like easy things to deal with. You can make a matrix. I so rarely make a matrix. Like, this just makes life easier. Coding like makes life way easier. I so rarely make a matrix. Number of rows, number of columns. See, it helps to like look at it. So there's the data and number of rows, number of columns. Okay. So our data is going to be, let's concatenate and let's go 2, 3, 2, 3. And we're going to make a square matrix here. And we're going to put in 2 rows and 2 columns. And there it is right there. 2, 3, 2, 3. And it goes like this. It goes down like that. So let's change this to an 8 right here, and you can actively see what's going on. I wonder what happens if I say, so it's rows and columns, so this will put in a 3rd column, and it's mad because, oh, it repeated, it just gave a warning message, but it wants me to rather put in like 10 and 1, so this will become 10 and 1. It's just saying you didn't put in the right amount of data. So if we have a square matrix, which now we're going to need 3 more values, we're not really concerned about how the matrix looks, and we really don't do this. So argument 7 is empty. Wait a minute. Oh, see, I made a mistake. I think you can get the determinant of this matrix. We're just going to make it into object M. This will now assign it to over here that M is a matrix. And if we go determinant of matrix, there's the determinant. I mean, it's important to know how to find a determinant. I can do a 2x2 determinant pretty quickly. Let's do a determinant of a 2x2. This is linear algebra. Just practice my linear algebra skills. So this matrix right here, let's look at it. It's going to be 16, 6 minus 16, negative 10 determinant. There we go. You don't need to know how to do linear algebra because it'll do it for you. You only took Calc 1 through 3. I love linear algebra. Linear algebra is like one of my favorites. And you can do like calculus with linear algebra. It's so cool. But all the things you can do, you can just do a lot of this inside of R. It'll just calculate it for you. It's like, hey, here's the determinant of a matrix. We can probably integrate. I should know how to write a function. I took an assembly class in Joko and created my own Alexa. Oh, that's so cool. I think learning how to code, and you should have an understanding of what things are. Like, what is a determinant? So could I tell you in words what a determinant is? I know how to find it, but I almost think my class has failed me that I can't describe the purpose of a determinant. I mean, gosh, like, what is it? If the rows are linearly dependent, oh, the smart mirrors are awesome. Like a magic mirror. I know what you're talking about with smart mirrors. Those are so cool, Adam. Like I would love to make one of those. I've actually wanted to do that as a project for a long time using like Kodi or XBMC, if you know either one of those. I'm a big fan of Kodi. I haven't used my Kodi machine in forever. Yeah, it uses a Raspberry Pi. Raspberry Pis are awesome. Awesome. Yeah, that sounds like a really helpful class, like really good knowledge. I wish I had more like woodworking or metallurgy skills. I sound like I'm playing an RPG right now, but I wish I had some skills in those areas. I didn't. I'm like, my skill level is like skill level 5. Really quick story. We need like story time with Brian. Um, I forgot to do something in Stat Tool 1. I'll have to do it at the start next class. I need to write notes like start class with this. So my dad and I were installing a wall mount for a TV in my apartment, and I was drilling, and I was like, and my dad was like, Brian, he's like, do it like this, and he showed me like 2 times. He's like, just give it to me. He's like, and he's like, did like 3 holes immediately. Thank you. He just is like, after the second time trying to teach me how to drill, he's like, son, you clearly don't know how to do this. I was like, Dad, I'll help you with techie stuff. I'll help you with the nerd stuff. You want any good anime recommendations, Dad? It's like, I failed at life. My son's an anime nerd. No, my parents are very proud of me. It's just, yeah. I took a woodworking class in high school. Oh, actually, you know what's funny? I took a woodworking class too, and it really was a great class. I probably was a lot better 20 years ago, but the woodworking class I took was really awesome. It was really, I took shop. It was super fun. What's even crazier is we had the teacher retired. So here, really quick story on that, because we're just chilling. We did a bunch of good work so far. We're just chilling. So the teacher started the semester, and he sadly he's probably passed by now, because the guy was like 70, 75, and this is 23 years ago. So he could be 100. You never know. But this dude was super old. Nothing wrong with that. But we had a book, and it was like the most boring class ever. And the class was seriously like him being like, okay, I want you to know that there's 10 types of wood, and you need to know the grain for this wood versus the thickness of this wood. And it was so like, it was just horrible. It was like, I was like, what have I done? This is boring. And then he retired, or he quit or something. He was gone. He just like, one day they're just like, you have a new teacher. And everyone's like, oh, cool. And this guy came into class. He's like, hey, what's up? So we're just going to start using the power tools. I swear, I don't know how much we were trained on them, but he's just like, let's start drilling. Let's start cutting things. And then we did all these competitions where we had to do like the egg drop. And he's like, you can make whatever you want. I think one time we had to like make a commercial. I would pay good money if I could find that commercial that we made, because we made like a cereal commercial, like advertising a cereal. So I remember I made a board with, I liked this like skater. I didn't even skate. I just thought it was like cool things. Like, but I made I drilled it into a board. Like I sketched it and then drilled it, and then like beveled the edges or whatever. So a lot of cool things. Sounds like mine was very different. We did about 2 weeks of lecture, and the rest of the semester was nothing but projects. Yeah, that's we definitely went towards projects. Like we would have like, for 2 weeks we're doing like, we've got to transport an egg, we've got to drop an egg. And we did, the way we dropped our egg was, I think we did the one where you wind it up on a pole and you let it fall down, but we figured out a way to do it. Really cool stuff. Mark Rober, if you've ever watched Mark Rober on YouTube, he's got really great stuff on like science projects and cool things you can do. But I think last little thing I'll say on this, is we're just relaxing, then I'll do some more code, is I think we learn a lot by experimenting. Like by, I made a spice rack for my mom and she lost it. No, make another spice rack for your mom. Make another one. Practice those skills. It's, there's just something to like, oh, you know what? Oh, you just reminded me. I made a napkin holder. No joke. I made a napkin holder for my mom. I need to ask her if she still has that. So the napkin holder, it's like flat, and then you pull up the board and you put the napkins in, and then it drops down on it to like keep them in place. But I made a napkin holder for my mom. There you go. So yeah, definitely. So I think because what we did is you take one board, then you drill 4 holes in it, and then you take another board on top, you drill the holes in it, and then you take the poles and put them in and just drop down. Maybe it only had 2. I don't know. I can see it, but I can see the color on everything. I stained it. Man, so there's a few things I did. Here's the thing. With all the classes you take throughout your life, it's pretty amazing to remember a few things you did in each class. Like, if you remember, I took every semester in high school, I had 8 semesters of high school, probably took 5 classes. That's 40 classes right there. Maybe even more, maybe 7. So that's 56 classes. You do the same for college. I've taken over 100 classes, high school and college. If you ask me to tell you 3 things I did in all those classes, you're asking for 300 memories. And sadly, I don't think I have 300 memories from school, even from if we were to go through all of them. I mean, sit down and start listing them. It's good to write down things and try to remember and go through. You took 2 film classes in college and watched nothing but movies. Best class ever. I did. You know what's funny? I took a class. What is his name? I hope he still teaches at UT. Really nice guy. He's in the poli-sci department. I did Politics in the Media was a good course. For part 3 on visualization 2, what does it mean by provide only the appropriate measures of center spread for the write-up? You bet, Maddie. Let's go talk about that. Thank you, Maddie. If we're just relaxed, and please feel free to ask questions at any point if I am just kind of, as we're just doing this right here, because we're just relaxing. But don't be like, oh, I'm interrupting. Nope. Okay, so how do we know what is the appropriate measure of center and spread? I'm going to go over to this graphic right here. So the appropriate... Exactly. The appropriate measures of center and spread. What is the first thing we talk about when we talk about quantitative data? What is the first thing? Kind of use this for hints right here. What is the first thing we talk about when we talk about quantitative data? What is the first thing we talk about when we talk about quantitative data? There's a hint on the screen. There's a hint on the screen. What is the first thing we talk about when we talk about quantitative data? The very first thing we talk about. And we will be covering this next class, Maddie. Like, we're going to, like, you're like, well, I haven't covered this. This is next class. We do talk about modality, and modality, great job, Maddie, right there. Modality is part of shape. So the first thing we talk about here is the shape of the distribution. The shape of the distribution has a few key topics in it. So the shape of the distribution is going to have the subtopics of modality, outliers, and gaps. So a distribution, great question right there, Hannah. A distribution just means like, so sometimes like, Brian, define that word. And I'll be like, okay, here we go. A distribution in statistics is I'm trying to give the best possible answer, is the way values are distributed across a sequence. This is a distribution right here. This is a distribution. Just think how they're distributed across like a number line. So when we say like a distribution, we're talking about like, you can have the normal distribution, you can have a skewed distribution. There's other things like you've got other kinds of data that make different distributions, but kind of how data is distributed across a number line. So hence distribution. No, really good question, Hannah, because even I have to pause to be like, how can I define this in such a way that if you haven't taken stats, which 201 did first stats course. So that is a right skewed distribution, and it is unimodal. So we look at the keywords right here. It is unimodal because it has this one clear peak to it. When you hear modality, think about how many mountains there are in a distribution. Now, what do you think about this last one? Would this last one right here be bimodal or unimodal? This is 1 mode, 2 mode. And what do you think about this? That third one above my head, is that bimodal or unimodal? And I'll go into greater detail on it. Is that bimodal or unimodal? And multimodal is just if it has like multiple modes. Like if there's 3, 4 modes, we just call it multi. So, and then we're going to answer real specifically how to answer your question, Maddie. Because this is super important, because when it says use the proper measure of center and spread, it's going to be very important. Exactly, Maddie. Great answer right there. I would probably say that this is unimodal. Like if I were to describe this, I would say that that is unimodal. So maybe I should put a 1 below it to make people understand if they're watching. Like this, I would say is pretty unimodal. There just seems to be some outliers towards the high side. Like there's a little bit of a, maybe you could even say there's a very small second mode. Does that make sense? Like you could say, or right skew, Adam, I think right. That could be just a unimodal distribution with a right skew with just a little bit more on the high side. So I'm not really going to call that a second mode. If there's enough data to create a second kind of modal area like that, I would say is enough. That's enough. But when you start to get into, there's a very few amount of points, it's like, is that really a second mode or just a symptom of the skew? So that is the modality of it. What we're really going to focus in on is the idea of symmetry versus skew. So when we have a symmetric distribution versus a skewed distribution, you got to remember this: right to the high, left to the low, whatever way the tail goes. Little monster dudes. Symmetric distributions are going to look symmetric. Symmetric means you can fold it over on itself. Please, if I ever say a word you don't know, tell me. Symmetric just means like our faces are usually symmetric, so you can fold it over. So we have a symmetric distribution right here versus the other ones are right skewed and left skewed. If you notice when I say right to the high, that means the tail is pulled out toward the high number line. Now I've color-coded these words for a reason, because when we talk about outliers and gaps, you'll notice that these are also red. So you've got these gaps right here. Stop changing my color. You've got these gaps. There's a gap. And these are all outliers. Frankly, everything that's a dot on there is an outlier. Lots of outliers. And notice the color coding. Color coding. So with the color coding, blue is symmetric and there's no outliers and no gaps. I said, what did I just say? And red is for when it's skewed and has outliers and gaps. Because when we get down to center, what do you notice about center right here? When we see center, what is the center of this blue distribution going to be best described by? The center of the blue distribution, the best measure of center for a normally distributed data set that is pretty unimodal, symmetric, doesn't really have any outliers, no gaps. That one's going to be best described by the what? The center for normally distributed data that is unimodal, symmetric, and doesn't really have outliers, doesn't really have gaps. So all these blue things right here. You're welcome, Adam. Great job. Great job. You're welcome to swing by any time. Good to see you here, Master. So getting those points. So center can be two ideas, the mean or the median. Maddie, that is a top tier answer, Maddie. That is totally it. Remind me to mod you in chat, Maddie. Be like, Brian, mod me when you're in class. But that's exactly it. And then what do you notice here about the color coding for, and don't worry, range, this is from yesterday's notes. It just helps that I kind of already have it plotted out. What do you notice here? And thank you, Maddie, for asking. Like, don't worry. Like, I want you to ask questions when you're like, I am stuck, Brian. And what do you mean by this? What do you notice here is that the topic of standard deviation is for this also, just like the mean is. So we can do better than that. There's not even green on the screen. This pen is possessed. Sure. There we go. Exactly. Now I want you to think about this, and I think we might still have it on the bottom right here. And so we put it right here. The mean always goes with the standard deviation, and the median always goes with the IQR. I should know I bet you I could figure it out. Good to see you here, Spencer. The median is the what percentile. The median is the 50th percentile. So when you think about median and IQR, the median is the 50th percentile, and the IQR is this distance. So both of these are based on the 5-number summary. So that's why they go together, because they're both concepts that are analogous. The mean, I so rarely have to, the mean is Y bar, and the standard deviation, and I do want you to know notation a little bit. It helps so much in the class to know notation. It should be, the standard deviation should be the sum, why not, if you really want to be green, the sum of the squared distances of each observation from the mean over n minus 1, that's variance, and that's square root. That should be standard deviation. I really wanted to cheat, but I mean, I should understand the formula enough to do it. That's sample standard deviation versus population standard deviation. And you don't need to memorize the formula. That one you don't need to memorize. I mean, you need to know the notation that y means an observation, y bar means the mean of the y variable, and n means the sample size. And so the sum of the squared distances for all, I guess we need a, I don't know, it should have the I sub, and then, sure, through all the i's. So I mean, you don't need to know this though, but I want you to see something key about this. The reason I did this is the standard deviation uses what to calculate its values? What is used in the standard deviation to calculate values? So the standard deviation is in part calculated from the what's. It's observations distances from the what. Because the y stands for observation, and then it's the observations distances from the what to calculate the standard deviation. Hence why it makes sense why these two are paired together as concepts we use in tandem. The mean, exactly. The thing I have highlighted right now is the mean, and that's, statistician's going to yell at me. The sub I goes, oh, now it's going to be blue. It's the ith observation, not the ith mean. Just noticed I put the I on the wrong one. There it is, because it should be the ith observation, not the ith mean. There is no ith. If you have multiple groups, there's the ith mean. So this is the mean of the data set. Y bar stands for the mean. So if you're wondering like what is y versus y bar, let's just mention that briefly right here. This is notation talk, which we should have an idea of. If we ask people their age. So we have 19, 21, and 39. Let's go with 20 on the other one. No. Let's make it 29. Make this 20. Sure. And what? Yeah, let's make that 19. I'm making life easy. Okay. What is a y value for this data set right here? With this very small data set I have, what is a value of y for this data set? What is a value of y for this data set? What are the y values of that data set? So just to understand notation, what are the y values in this data set? What are the y values? Like what is a y value in that data set? So the y's are the observations. What is a y value in that data set? When we say like, what are the y's? 20 is a value. Yep, that's just an observation. 21 is a y value. So it's just the observed values. Does that make sense? Like these are the observed values people said, and then I made life a little bit easier. And then y bar is the mean of the data set. Does that make sense what y bar is? So this one, 20 is a observed value, but 20 is also the mean. If I wanted to make this more complicated, what would y bar be now? What would y bar be of this data set? I think I can do it in my head. 40, 70. Yeah, I think I got it. Okay, I got it. Figure out what y bar is. First person to figure out y bar, we're going to give 20 points to the whole chat again. What is y bar for this data set? We're going to give 20 points out again. I like giving points during office hours. What is y bar for this whole data set? It's a very small data set, but what is y bar for the whole data set? What is y bar? And I'll show how to calculate it here. What is y bar for that data set? You're exactly right, Maddie. Nice job. Let me put the points in the chat. Great job, Maddie. Get 20 points, everyone, right there. Little 20-point bonus. So you just add up the three values, and you divide by 3, and there it is right there. Great job, Maddie. That's it. That's y bar. And so the y, there's multiple y observations. Like that's a y value, that's a y value, that's a y value, and then y bar is 23.333, which is the mean for the data set. Does that make sense? What y and y bar, and then what would n be? Do you know what n would be? Like, you do not need to solve this by hand. You are not going to solve this. I joined later if you've already gone over visualization 2. We can go back over it if you want, Parker. We did it yesterday and today, but ask questions, Parker, if you want. Like, be like, hey, Brian, can you explain this? I can bring up the visualization 2 notes again. And what would n be for this data set? What would n be? So ask any questions you want, Parker. Good to have you here, Parker. What would n be? How can I drink coffee and get tired? Do I need another sip of coffee? N stands for number of observations. N stands for number of observations. And Y sub I is just like each individual observation. 3. You're exactly right, Maddie. Yep. You don't need to solve this because here's how we solve this. You go to jump, you open up a new sheet, you type in 30, 21, 19, you go to analyze distribution, you double click, you click OK, and there you go. So if you're seeing, this is how we're not going to solve this by hand. We're not going to solve them. I mean, we want you to solve the mean by hand, but this green one you'll not solve. The standard deviation is 5.85. It's solved for you like that. You're not going to work the standard deviation by hand, which is something I put into the modules for the asynchronous course. The median is the middle number, which we can see is 21. They're not quite in order. They're reverse order, but all this right here. Parker, feel free to ask any questions and we'll be like, I'm stuck on this, and we'll go through. But I think I don't teach till, 5:10? I think so. Might cook some rice, make some stir fry. Oh, I don't know what people are having for dinner. But does this make sense, Maddie, what your requirements are? I think Maddie just finished visualization 2. We were talking about it just a moment ago here, Parker, about what are the proper measures for center and spread and understanding when to use the mean and standard deviation and when to use. And let me draw something out right here. This diagram should help a lot. So pay attention to this diagram. I'll probably draw it in class 2, but if you know how to draw this, you'll be ahead of the game. Yeah, good job, good job, Maddie. So let's go here and let's say center and let's say spread. And we're going to have 2 different distributions. We're going to have this one and we're going to have this one. So we've got normal data and we've got skewed data. So if data is normal, what is the measure of spread center we should use? I keep portmanteauing words. If data is normal, what is the measure of center we should use? If data is normal, what is the measure of center we should use? And if you can draw this out and memorize it this way, it's really good. Like the measure of center for normally distributed data will be what? When it's unimodal, symmetric, like the more like unimodal, this is one mode and this is the symmetry right here. The more it looks like this, the more we're going to use what for the center? Because it won't always perfectly look like this, but you're like, my data is pretty unimodal symmetric. Okay, that seems like a good idea to use the... I try to answer to you guys again, but make sure, because maybe someone's like, wait, which one do we use again? Mean. And then if we don't use the mean, what's the other measure of center when the data is skewed? If the data is skewed or has outliers, then we would use the median. So one thing you should immediately know right now is that the measures of center for the class are going to be the mean or the median. Modality is still an idea of like where's the central tendency in the data to say like the modality of it. Modality just means an area of concentration of data. Like it can be unimodal, bimodal, and have concentrations of data. But what is the proper like central tendency? Like where is the data centered at is either by the mean or the median. Now, why don't we use the mean for this data? Like why, if there's even outliers over here, why don't we use the mean? Because maybe the median is here. What would happen to the mean for this data? So why don't we use the mean for this data? What happens to the mean when data is skewed? The mean will follow the skew. The mean will be inflated or decreased. The mean will be influenced by the skew. Does that make sense? Like you don't want to use the mean for this data because outliers could greatly influence the mean. We can see this firsthand with the very small data set we made. Let's go over here to this very small data set. We're going to put on autocomplete inside R, which is a jump, which is a really neat feature in jump, or auto recalc. That's what I was going to say. Automatic recalc. And watch this. Watch the mean right here. Let's change this to an outlier of a 90-year-old. Well, now all of a sudden the mean is hugely increased. Well, if it's a data entry error, well, now it's 313 is the mean age. But look at the median. The median does not change because it's not influenced by outliers. So the median is not changing, just like the IQR is going to be not influenced by outliers. We need a bigger data set because this is just such a tiny data set right now, because you'll notice the IQR will not change as long as I have more than 3 values. And let's go ahead and put in this as 900, and the IQR is 2. The IQR is the distance between these numbers, and that tells us that the IQR goes with the median. The IQR is the measure of spread, and we were just talking about earlier that the standard deviation goes with the mean. And this is big right here. So huge thing to have written down right here that, and let's put more notes, but if you have these notes, if you can draw this out, that the mean is going to follow the skew. You don't use the mean right there. You want to use the median. Oh my gosh, I was thinking X. And so you want to use the median. You do not want to use the mean because the mean is going to follow the skew and it's going to be inflated or not a proper measure of the data. This is a big note to have right here. It's a good little chart to have. You'll know your 2 measures of spread, your 2 measures of center, and you'll also know when to appropriately use them and some concepts like shape and modality and all that good stuff. Maddie, Parker, what are you thinking? What questions do you have? Did this help out, Parker? Because this is for one of the visualizations, when to do certain things. So feel free. Chat got so quiet. Chat got so quiet. We had morning office hours. As we start to get more assignments, office hours get a little more crazy. And so glad people come by, getting some points, asking questions. Spencer swung by. Scott. Oh, Parker, awesome. What other questions are you working on, Parker? So feel free to ask. Like, Brian, I'm working on this. I don't understand this. Feel free to ask. Because someone who's watching this video later will be like, oh no, if they had just asked this. And you can always put comments on the videos. You can always ask questions in the comments that people can look at. So I appreciate any comments, any likes. Don't like videos though. But any comments, any likes, anything else like that interact with the videos. Because my goal, this guy, Professor Leonard, he teaches calculus on YouTube or teaches mathematics. And I really want to be like, I don't know. I like the idea of free education. Reading number 3 right now. Can you go over skew, gaps, and outliers? Yeah, of course, Parker. Let's talk about that. So let's hop back here. Okay, I'm going to erase some of the things on this slide or this thing I've created. So this is just a different distribution. But when it comes to over skew, so skew is a concept within the shape. So let's bring all of this. I'm going to erase. Really? There we go. Okay. So when we talk about shape has 3 key concepts inside of it. It has modality, skew versus symmetric, outliers, and gaps. And please take note of the coloring I put on here. Didn't even know what I said earlier. That it's directing you towards which one applies to which topic. When we talk about modality, things can be unimodal, things can be bimodal, things can be multimodal. If it has more than 2 modes, we just usually say multimodal. We usually want there to be clear peaks between the modes. Like, I wouldn't really call that bimodal. That's like still unimodal with a little bit of right skew and outliers. At the point at which we would maybe consider it a mountain, like some people might call that bimodal. I might. This is going to be definitely bimodal. That's got a second concentration of area. Modality just means there's a concentration of data in that area. Like, this is probably where the mode is at, but there's 2 modal areas. Like, when people think of mode, it means most often, and there's 2 most often areas. That's what modality is. So modality just means kind of an area of concentration of data. So when you think about symmetric and skew, we have here right skew, and we say right to the high, left to the low, whatever way the tail goes. How dare you change colors on me? So when you look at this little monster dude, if his tail goes to the high side, he's right skewed. So just check out the monster's tail right there, and that is a right skewed distribution. The data has a pull to the high side. And what does this mean when it's right skewed? Really great question here, Parker. You ready? When a data is skewed to the right, the mean will be higher or lower than the median. This is a good question. It's appeared on tests before. When the data is right skewed, the mean will be higher or lower than the median. And if you want a tip, or if you want like a hint, look at that. So when the data is right skewed, the mean will be what to the median? When the data is right skewed, which means it looks like ours right here. The mean will be what? And the hint is going to be that the mean follows the skew. So the mean, when it's right skewed, the mean will be higher than the median. So when it's right skewed, the mean will be higher than the median. Exactly. Great job, Parker. So the mean will be higher than the median, which we see in this data set. And that's because think about it, like if we had a data set where it was like 1, 2, 3, 4, and then like a big number like this big number, which is going to be like a right skew number, is going to inflate those numbers down there. It's going to increase the mean. So the mean will follow the direction of the skewness. So because of this, we would not use the mean, we would use the median. And that's why I color coded this red down here. So if you notice, these ones in red are when we use the median. So, and also when we use the median, we will also use the IQR. So that's the IQR down there, if you can see. The other things, what are outliers and gaps? So a gap in the data will generally create outliers. So when you look at for a gap in the data, you're looking at something like this right here. That's a gap in the data, and everything is all outliers. So outliers are extreme values. They can be high or low, but if you see these dots in box plots, those are going to be outliers. So we see a bunch of outliers, and we definitely see a gap between the, it's really interesting that there's that gap right there. It's just so weird. From about 1500 to 2000, there's a big gap. There's smaller gaps, but that's probably the most influential gap right there. And I wonder, because this is real data, I think, I wonder why it is that there's just a gap between when people make like a big application or a really big application. So there's a gap in the data up here, and over here, these are all the outliers. Now, one important thing to note is all of this means we should probably use the median and IQR. So when we talk about what's the proper measure of center and spread, we have to take a look at those concepts we just covered, and we also put this on the chart a moment ago. But we need to decide, my pens are possessed. We need to decide if we should use the mean and standard deviation together, or if we should use the median and IQR. We don't combine them with like the mean and the IQR, or the median and the standard deviation. But all of this is based on the shape of the data. So it really brings us full circle, really good full circle right here, back to this, to where if the data is more normally distributed, we use the mean and the standard deviation, or if the data is kind of skewed with outliers, we're more likely going to use the median and the IQR. Is this making more sense, Parker? It's really good practice right here, and just knowing these concepts and be like, okay, our measures of spread, our standard deviation and IQR, they tell us like how far the data is spread out, where the measures of center are mean and median, which either tell us the average of the data or tell us the 50th percentile. Standard deviation is a typical distance things are away. So one standard deviation, I want it to look proper. That's about where one standard deviation is at. It's like a typical distance. So that's one standard deviation. That's like one standard deviation away. So where the IQR is going to be the middle 50%, the range of the middle 50%. So the IQR is going to be something like this. Like that's the IQR. So the IQR is going to be the distance that is away. It tells us a spread of the data. You see how that's like a spread of the data? And then the mean is going to be here. And the median is going to be here. It doesn't have to be in the center of it, so let's show that. Sure. And we'll put an arrow. So it doesn't have to be directly in the center of the IQR because data doesn't have to work that way. So if you notice, the median and the mean give us like a center area for the data, like where's the middle of the data. So that tells us kind of like where's the middle of it, where these tell us how far is the data spread apart. So this is kind of a really good visual display right now to see that the spread tells us like a distance things are away. So the IQR and the standard deviation are spreads of data. So take this down if you don't have it, and hopefully the color code. You can screenshot this. You can do whatever you want. Put in your notes. You need to talk about them. Yeah, let's talk about that real briefly here. Definitely, you need to describe them, and I think I have notes on that up from yesterday because we took really good notes yesterday. Here it is. Okay, here we go. So when we do this right here, we need to interpret it. So the IQR interpretation. The IQR interpretation would be the range of the middle 50% of the data for whatever variable we're talking about is blank. So if we go and take our data set right here, take a moment and tell me about the IQR here. These are the ages of students. This is a crazy data set. It doesn't really make sense. But tell me about the IQR for this data. Like, describe it in context. The range of the middle 50% of the data for blanks of blanks is blank. How would you describe this? What is the IQR from this data? It's got an extreme outlier. This data is not real. No one's 9,000 years old, as far as I know. But what would be the IQR interpretation right here? What would be the IQR interpretation? And then we have to calculate it. And if you want to cheat, not cheating, but it makes life easy. I mean, you can calculate the IQR very quickly right here. No, just in case anyone like, Brian needed to cheat to calculate the IQR. I swear I know what it is. It's 2. So how do we interpret this? How would we interpret this value? And that's a big thing we do in our classes. We interpret the value. We don't just say the IQR is 2. So we could say the IQR represents the range of the middle 50% of data for, I need someone to help me out right here. I need someone to help me out. What is it going to be? The range of the middle 50% for data for what? Really good office hours. Covered a lot today. We did coding. We talked about interpreting data. So what would it be? I am stuck. I do not know answers anymore. This is when someone's watching in the future like, what is the answer? What is it, Brian? Well, let's say this is the context of the data. What are we talking about? The range of the middle 50% of the data for the ages of students is 2. That's what it is. That's the range of the middle 50% of the data. It's 2. And then let's look at our standard deviation, our median interpretation. There we go. The 50th percentile for the age of students is 20. There we go. That's what the median represents. Is the 50th percentile for the age of students is 20. Is this making sense right here, Parker? That the median represents the 50th percentile for the age of students. I had written it yesterday, so I can rewind time all the way to yesterday. But the 50th percentile for the age of students in this survey, we could say, was 20. And we get that from right here in the quantiles. So hopefully that makes sense in how to interpret this. And we always give context. What does data need? It needs context. We know that. Let's see right here. We'll see if there's any more questions. We might hop back into space right here. I need to work on Mubot's voice. There's a few things I have to do with like buttons. Keep thinking about organizational stuff. I think that's got it. We'll see if Parker has any questions or anyone. If you're here right now, feel free to ask a question. One thing I always want to say is when you're welcome, Parker. Anytime you jump in, like if I'm teaching something, add the question because I'll always do the questions like when people ask them, like I'll put them in order. I used to wait tables and I'd have a list of things in my head I needed to do. So just keep adding to that list. So if you ever come in here and I'm on like over here and I'm talking about coding or something and you're like, oh, he's not covering 201, just put in the chat like for visualization number 2. And then I'll usually be like, oh, we'll do that next. Or like, sometimes if the day's super busy, I'll be like, oh, we covered that at the start of the thing. If you rewind, you'll find it. Cause like, if there's like 10 questions and I'm like, sometimes I'll do like a priority thing, but always put your question in here and I'll address it or I'll find some way to be like, check out this or something. But especially when it's slow, I mean, even if it's busy, I'll help out. And yeah, but thank you so much, Parker. Here, we'll hop to space right here. Let's go to space. Back in space. I call this space. It's like my command station. So I think that does it. I've got so many buttons I haven't even used yet this semester. I guess we're going to start class with that thing next time. Oh, I should do that. I know what I'm going to be doing tonight. I've got something to make. I think that's got it. I'm going to respond to some emails, I think. Really good office hours today, this morning, and this afternoon. But with that, let's play some music. Let's put on some nice music and just see if anyone has some questions here. I've gotten to like this music. It's just nice. Relaxing music as we get to the end of office hours. Can you send the Discord link? Message me, Spencer, and I'll send it. Tell me if the link doesn't work. We have to update it. It's just so people can't post the link anywhere and people spam our Discord. So Spencer, make sure to email me and I will send you it. Spencer, I will get to that link from your UTK account, of course. So email me from your UTK account and I will send it out to you. And that'd be awesome. We're all about that. Want to help out students. And I've got 5 messages on Discord. You're welcome, Spencer. I really appreciate it. So it's just, you know what's really nice is like, I really like UT has the saying, you know, vols help vols. A vol means all. Because we should really be there to help each other. We should, you know, when people are stuck, when people have questions, when people are feeling down. Because, man, it's, I don't know. I'm getting all sentimental listening to this music now. I've just had times in my life where friends have really helped me out a lot. We've all, you know, been through rough times. You don't get through them on your own. You don't, I'm not trying to like, but it's true. It's true. You don't go through, life's not a single player game. Life's a MMORPG. It's a big world. You need people for your quests. When you get to a chest in life, like the prizes, it's better if you have friends there to share those with. You don't just go up and say, give me all the rare items, give me all the good stuff. You go up and you say, hey, there's this really cool item and I think it could help you out. Your friend says, oh, thank you so much, but you should take it. You're like, no, I'm good. You'll help me out another way. You'll get me back. You got this. And that's what we do in life. Sentimental time with Brian. But, you know, keep that in mind. Keep that volunteering spirit in mind. That's what we're here to do on Rocky Top. I might not be on Rocky Top, but Rocky Top's here. Or here, wherever my heart's at. With that, it's the end of office hours, everybody. I will see you later. I wish I could play the music through the outro. I'll figure that out. Bye for now, everybody. Bye!